I know I told you to do just part C on, oh, by the way, we are looking at the year 2009 BC4, and again, I told you to do C only, but that was before you hopefully watched the Euler's method videos. And so if you haven't watched the Euler's method videos, I would like you to pause the video right now and then come back and try to do part A, Euler's method, because I'm going to show you the solution to that in just a moment. So that's my challenge to you. Can you watch the Euler's method videos, understand the process, and come back and do an AP free response question involving Euler's method? And that would be really great if you could. So I challenge you to pause the videos now and the video now and go back and learn Euler's method, attempt part A, and here we go. You should have gotten 17/4 as your answer. It says 2 steps of equal size starting at -1. So when x is -1, we have our current y of 2. Okay, so when x is -1, current y of 2, I've got a little diagram over here. So when x is -1, y is 2, and we know that the slope at that point, using this formula for the slope, because that's what it says, the slope is 6x squared minus x squared y. We plug in our x of -1, and we plug in our y of 2, and we get that the slope there is 4. Okay, so when the slope is 4, we know that the next column gives us our new y. Oops, I was talking about it, but I'm not pointing to it. So we know we have our new y of 4 because the new y depends on the current slope, the change in x, which if it's 2 steps of equal size, and we need to get from -1, go over the diagram here, if we need to get from -1 to 0, then our change in x is 1/2. We're going to move 1/2 unit to the right. So that's our change in x. So change in x equals 1/2. Okay? And so 2 steps of equal size, 1/2 on the first one, 1/2 on the second one, we get all the way over to 0. And that's what we're trying to do, figure out what our approximate value of the function is at x equals 0. So brings us back to the chart. We have our current y, or sorry, new y, is our slope times our change in x plus our current y of 2, and we end up getting 4. So our new approximation when x is equal to -0.5 would be 4. Okay, so that becomes our new, or sorry, our current xy. So we think that the function is at 4 when x is at -1/2. Repeating the process, we get the slope is equal to 1/2. If the point were in fact at -1/2, 4, the slope there would be 1/2. Given the new slope, we plug in still our change in x, doesn't change in our problem. Change in x is 1/2, slope times 1/2 plus our current y, and we get our new y. So this becomes our new y, and that is our approximation for y of 0. Okay, approximation for y of 0. And that's the answer. So that took 3.5 minutes. Let's go ahead and do, I'm going to do the next one. I am going to do this one. Sorry, changed my mind. So here we are, part C. We're trying to find the particular solution to the given differential equation. I took the liberty of factoring out the x squared, and if you don't do that, you get kind of lost. So anyway, you need to do that. And then you need to divide both sides by 6 minus y. At the same time, you're going to multiply both sides by dx. A separable differential equation. Now, up until, well, I think most of the problems that we've been doing, the y has been positive, and that way du is the same as dy. But I want to just show you that it's important to remember that we need to do a u substitution here. So if u, because we're going to be integrating, u is 6 minus y, du is negative dy. That means that if we want to substitute for dy, we have to put a negative du in place of the dy, which then would look like this. So we get the integral of dy, which is negative du, and that's over u. Okay, is equal to, we can do this one, x cubed over 3 plus c. Okay, and then we know the antiderivative of this is negative ln of the absolute value of u, and I'm just going to plug in the 6 minus y. Okay, so that's the trick there. And then when we get to this point, don't convert to exponential yet. Make sure you divide by that -1 first. Okay, if you divide by -1, get the log by itself, then you can convert to exponential. And x cubed over 3 divided by -1 is negative x cubed over 3. Now c divided by -1, well, again, we get a lot of liberty with the constant. C divided by -1 is just another constant, so we're going to make it the simplest constant we can find. And now we're able to convert this statement, which is a statement using logs, to a statement using exponents, or exponential functions. So e to the negative x cubed over 3, we're going to multiply by e to the c, which then turns into a c, and then we get 6 minus y. So we don't need the absolute value bars because we know the right side, or the left side, is never going to be 0 or negative. And let's bring the y over here, and we'll bring the c over to the other side, c term, and we get that. But we have to use our initial condition. Remember, our initial condition is that f of -1 is 2. So y at -1 is equal to, I need to slide this baby up, y of -1 is 6 minus c times e to the -1 cubed over 3. And that has a value of 2. Okay, make sure. Going off memory. Yeah. So that equals 2. And so we're going to take this part of the equation. It's kind of bad to put an equals there and equals there. But we need to solve for c. So how are we going to do this? Alright, you're going to subtract 2 from both sides. We get 4 equals c times e to the 1/3. Okay, and that means that we get c is equal to 4 over e to the 1/3. When things start going in this direction, you're thinking, oh my gosh, it could not possibly be right. But in fact, it is right. Probably easier to write c as 4 times e to the -1/3. Just bring it right up there to the main level here. And so we get y of t equals, and we have to find our, sorry, it's not t, it's y of x. Let's just leave it as y. I don't want to redo this whole video for that. So it's just y equals 6 minus c, so I'm looking back up here, c, which is 4e to the -1/3, multiplied by e to the negative x cubed over 3. Not a big mess, but nevertheless, if this were an FRQ, you could leave it just like that, okay? But the actual answer, the simplified version, remember when the bases are the same, you add the exponents, so you'd have 4 times e to the -1/3 minus x cubed over 3, and that's about as good as we're going to get for this particular answer. But yeah, that's it. Sorry to say, it is not very pretty, but that is the answer. Okay, hope you got it right.